There is a homework assignment on Canvas that is due this Monday. It's called Exercises 1.1. The 31st. Okay, so there's a handful of questions that I'm still waiting for answers on about like what the homework should cost, where to buy the homework, do you need a code? Still kind of waiting for a response on those, but I do have an answer about an issue with the bookstore. Some students, not just our class, but other stats classes too, were accidentally charged $65 automatically by the bookstore for stats. That was just a miscommunication between Pearson and the bookstore, and that charge should be removed. And if it's an issue, they said to contact the Bursar's office, which I'll write all of this as an announcement today. So if you were charged $65 for a stat lab, that will be removed. And then I put an announcement about how to create your homework account. If you have trouble making your account, there's a different announcement on how to go get help from someone who works at Pearson. They have an office hour today, and I think, let's check it out. This must be today and maybe. The 26th and the 27th, today and tomorrow, from noon to 1:30. Again, this is posted as an announcement, but just to highlight the important parts, it's the 26th and the 27th. From noon to 1:30. For now, I'm going to also post an announcement about PAL, which is a place to get more help on your math classes, including statistics. And later in the semester, I will tell you where the math lab is, but the tutors there aren't always comfortable with stats, so you never know if you're going to get help if you go to the lab. But you can get help from PAL. I'll give the details on an announcement in Canvas later today. Peer-assisted learning. Students from Stack State who know statistics can assist you with learning the materials. Okay, so we're doing notes for section 1.1. And we talked about a population being all of the people or items we're interested in studying. A piece of that population is your sample. And we looked at an example, picked out the population and samples. And now we're going into types of statistics. There's two types. One where you have all of the data you need and you organize that data, which is descriptive statistics. The other is where you have some data, you draw a conclusion on that data, and then you apply that information to the whole population. That first part. There are two types of statistics. By the way, I am so excited to work face to face because we'll have a full whiteboard and we get to meet each other and work in groups. This is okay for now, but the classroom will be great. Okay, we have descriptive statistics. Okay, that's where you just organize and summarize data. So you have like a small population in which you know all the information about that population and you can just learn about that set of people or items or things. Okay, so you have that info from your, you just organize that info. And this is when, or we use this when you know all of the information about your population. So you have all the data that you need. The second type is called inferential statistics. It's where you infer something, like you know something about a sample, and then you apply it to the bigger set. And you do that because the bigger set is too big to collect all of the data from. So you get an idea of what's going on in that set by studying the sample. This uses methods that takes a result from a sample and extends it to the population. So think of it like descriptive statistics describes what is going on. Inferential statistics understands what's going on with a sample and then applies that to the whole population to get an idea of what's happening in that population. So we use inferential statistics when the population is too large to collect all of the values of the data set. So those are the two types of statistics. I have these notes. So on your homework, you might see some information about variables, or it says qualitative or quantitative. And I have all these notes here, but I might save them for later. I'm going to save it for later. Okay, we are going to start to talk about, I'll just talk about it, but later in the semester, we will do actual notes on qualitative and quantitative variables. Qualitative is like a quality. Like eye color can be green, blue, hazel, so on. Or it could be season of the year. And that could be summer, spring, winter, fall. So qualities that your variable can take on. Quantitative variables are measurable. So something like height, you can measure. You have different heights of a person, or the length of a football field is measurable, and that would be a quantitative variable. We'll do qualitative variables and quantitative variables later. I just want you to know that they are in your homework, and there's something we are going to study, but right now it's a goal of knowing the difference between inferential statistics and descriptive statistics. Then we're going to skip to two different kinds of studies. There's an observational study or an experiment. Okay. In an observational study, you observe and take notes. I think I'm hearing some kind of sound, and I thought it was in my, I think it might be in chat or something like that. So I'm just gonna make sure everyone's on Zoom so I can kind of focus. But of course you can unmute if you want to ask a question. Okay, All right, so you observe characteristics and take measurements. You don't apply any type of treatment. You don't even get involved. You're just on the side, out of sight, taking notes. In a designed experiment, you do apply a treatment, but you also have a group that's called a control group. So there's one group you leave alone, that's your control group, and there's one group that you apply a treatment to, like say the control group gets placebo, or let me think about this. I think even a placebo would be considered a treatment. Like we'll get there. I'm jumping ahead. Okay. Okay, so the control group is the group that you leave alone. You don't change anything going on with that group. The treatment group is the group in which you make some kind of change to see what would happen after that change is made. And then you observe characteristics and take measurements. And so we apply some kind of treatment. As a side note, when we go through this semester, it may not seem much like math. It's going to be a lot of vocabulary. And then sometimes we'll use math to do the organizing and the summarizing. But overall, we kind of learn a lot of definitions, a lot of vocabulary, and just understand like what our process is. And we're not going to do like math all the time. I'm just going to use math sometimes. Okay, so I have examples. Do drivers slow down at yellow lights? So that would be my question. I'm a researcher. I want to go study this question. So what we're going to do is an observational study. That's one way we could find an answer to that question. So I could stand by the road, out of sight from all of the drivers, and just record what happens through the day. So of course I want to be near some kind of light, like I guess it's called a stoplight. I never looked up the name. Intersection. So there's no research intervention. I don't apply any kind of treatment. I don't affect anyone on the road or their behavior. Okay, next one. You want to know if athletes who are given specific goals perform better than athletes who are not given those goals. I'm a bad speller. Athlete, I-T-H-L-E-T-E. Okay, so that's my question as some kind of researcher and I want to go find out how to answer this question, I would do a designed experiment. And I'm just thinking, like, it's not like you have to pick one or the other to learn about to learn some kind of answer to that question. You could do a designed experiment and an observational study. You would learn something from both of those attempts. But let's say at this time I want to try to do an experiment. All right, take a class of students and divide them into two groups. Which is more accurate? So if asking which would be a better choice, I think it would depend on the question you're asking. But also, again, I think they're not one's not better than the other. They're just different, and they would probably both show similar results, but not the same results. So it depends on the situation. Maybe you can't even, maybe it's a situation where you can't apply treatment, so you can't do an experiment or something like that. Anyway, we'll see what happens. You never know. Just practice and try, see how it goes. Not in this class, but in most classes, it's a matter of doing a lot of scratch work and making mistakes until you figure it out. Okay, so we're going to have two groups. Actually, I'm going to check that out. That was a good question. I'm going to be sure that I answered it correctly and Google it later. So are there certain situations in which one type is better than the other? Thank you for the questions. All right, so, and then they have the students do as many pull-ups as possible in 90 seconds at each class meeting. Maybe sit-ups or something like that. But just by the way, on campus, over near the pool, there's a little kind of workout area that I really like to go hang out at. And it's got like pull-up bars and some huge tires and just a little exercise spot over by like these big fields and the front entrance. So like that would be possible. We could go over there and do some pull-ups. On that note, when we get, yeah, I can't wait to meet in person because we can actually interact with each other. And I hope, well, I will try to make experiments that we actually do that are just kind of fun games, really. But we'll take notes, collect data, organize that data, draw a conclusion. So sometimes we might go outside and do a little experiment just to get practice. But I won't make you do pull-ups. We'll just do something fun. Okay, so one group is told nothing. So that's your control group. Leave them alone. No influence. The other group is encouraged to increase the number of pull-ups they do by 10% each day. So this is a group that we've given some kind of treatment and we've influenced this group. And then that would be our designed experiment. Just see what happens, record the results from this group and that group, and then organize all of that information and draw some kind of conclusion. I have that in an experiment, the researcher can identify cause and effect. Aha, this is probably where we get a little bit more into which study is not necessarily better, but does something other than. Okay. So this is like, I guess, the difference between the two, what you can expect from doing one type or the other. Observational studies don't allow the researcher to claim causation, only association. So like that example before with the cars on the road. By doing an observational study, I could just say that yellow lights are associated with people slowing down. With the other experiments that I did, let's say those people who were encouraged to do better did do better. I could say that it would allow me to claim that it was because I influenced them. So observational studies just lets you know what's happening in that group. An experiment can let you know if you make a change to that group and it a change in that, let's see, how is it? The treatment applied to that group could cause a change. That's their causation. Let's see. I think I'm going to do a little bit more of the notes. So I skipped over two kinds of variables. Yes, we're going to go back and write that stuff down and then call it good. So there was qualitative and quantitative. Qualitative is for quality. So this is technically from a section coming up soon, but I think it's good to talk about it now. So these are kind of side notes. Qual, Q-U-A-L, qualitative, quality, and then quantitative for quantity. Also, just to be clear, we're going to put down what the variable is. So a variable is a characteristic that can assume different values. Like I mentioned before, eye color can be different colors, like blue, green, hazel, brown. Or like another example could be your variable is the number of students in a class. Maybe one day it's 24, maybe the next day it's 19, and then another day it's 23. So the numbers can change, but those numbers are representing how many people are in class each day. Okay, so we've got variable. For qualitative variables, they produce data that cannot be measured. Okay, these are values of your variable that can be measured. So they're numerical values. We're going to draw a quick picture, and then we're going to wrap it up for today. When we come back next time, I'll do examples for these two types of variables. Okay, so we start with the idea of a variable. And there's two separate kinds: qualities, quantities, qualitative, quantitative. And later we're going to go further and separate the quantitative variables into discrete or continuous. We'll probably just jump into that next class meeting, so we'll go ahead and add to the picture. But we haven't talked about it yet, so don't get nervous. We're going to lead up to these two types: discrete and continuous. So these are like little different values that you can take on, like 1, 2, 3, 4, 5, or counting numbers, or a finite list kind of idea, a finite list of values. For continuous variables, it can be any, your variable can take on any value on an interval of numbers. There's infinitely many values that your variable can be. And we'll practice those, like distinguishing those maybe next class. Okay, so we're gonna say goodbye. I'll see you Friday. Thank you, everybody. Okay, have a good day.
I have one quick question, Professor.
For sure.
Can you go over what you said about